Hey there! Welcome to this UcamX 2021.04 release video. My name is Sylvia Lima and I'm with UcamCo Belgium. In this video I like to show the highlights of our newest UcamX release in words and of course in live demos. The roadmap through this video is the release overview, which you can find on our homepage ucamco.com in Software, UcamX on the Release Notes tab. As you can see, we are always aiming to be a step ahead. The highlights of this release are extensions to our Netlist, to the whole YELO suite, for example Copper Adjuster, Legend Adjuster and Mask Adjuster. The reduction of the file size from secure edge compensation. A brand new Ledia hot folder output. We optimize the ODB output. And of course in the background we have a lot of code changes which makes our software faster, better, easier to handle, whatever is needed. Let's start with the Netlist extension. Our extension to Netlist is a resource-conserving update of net numbers for test, mid and pro players corresponding to the newly calculated Netlist information. Let's have a closer look on that. I will use a standard job and create a netlist for that. And I create my U-test, test point layers. And if I have now a closer look to the test points and put the signal layer below, then we can pick the net numbers and see directly that the signal layer and both test points are selected with the net number 126. If I now go there and delete the connection between the two pads, normally now I would have to go there and run a netlist, update the test layers and so on. I don't have to do that now. I go to build job netlist and directly if I go to pick net, I see now a number 136 only on the top one, and on the bottom one it's 135. No manual additional work is needed. Next part on our highlight list is all about our copper adjuster. Ring faults for plated slots are reported and repaired now. Mechanical wire holes can be expanded to fulfill the minimum hole size requirements. Plane adjustments optimizes bridge cuts into the contour to prevent unnecessary pads. A new option to exclude text and non-functional data. That's all nets without pads or all objects with the attribute for non-functional are excluded now. We have an improved GUI with tab pages, which makes it much easier to handle. And we have 4 new verify parameters to give precise control over slot rings. So let's look it up. This is our YELO job and I prepared it already and let it run through. So if I now have a look at some plated slots, you see that to the original they are much bigger, but we only add as much as needed wherever it is. So smaller here, bigger there, all around. It is the value I set into the component slots for optimum or minimum ring. Then we go to another place where I have in the original very small holes. So you see the very small holes in yellow here and here. After copper adjuster is run through, it looks like this. So I have the value I set in here for the minimum hole size, 0.15. After that it will go to the annular rings and we'll use that to fulfill the requirements set in here. If we have a look at a small plane area on this layer, you can see directly that to the original, the bridges are cut away very nicely to get the clearance we need, and everything is nicely rounded. In older versions we used small pads to create these nicely rounded corners. Now in the newer versions we don't need that anymore, and the data is completely cleaned up and therefore much smaller and easier to handle. Let's have a look at the new GUI. We split it up in 3 tabs: the verify parameters, adjust parameters, and the options. All new features we have are included in here, for example the minimum hole size, of course excluding the laser wire, because for the laser wire you can set a different value. We have the 4 new values for the component slots and mechanical slots, minimum and optimum ring. And we have split up the definition of a pad into wire pads and into land. Land is everything component, BGA or SMD. So you can have different values in here too. On the options side, you have the toggle to activate the exclusion of the nets without pads. If you don't toggle it, it will adjust every copper object, and if you activate it, it will ignore all nets without pads. For the manual exclusion, so for example if you have a lot of impedance lines or something like that you want to ignore, it is an attribute you can set with a category YELO, and then the name is in the list, the CHA exclusion. If you set it on your selected objects, then they will not be touched. The next part of our YELO suite is the Legend Adjuster. The Legend Adjuster contained in the older versions already a functionality to scale a text one by one. So I click the text and make it smaller or bigger and let it drop down. We now have a new option to scale all texts in one go on all active layers. It always preserves the minimum line width. Let's have a look how that goes. This is a standard job and I will use this one here. So if I open my Legend Adjuster, first I go to the text definition. I see with my small frames around it, which is put together in one text. I can go to verify and, for example, use a line width of 0.15, a line length 0.2, and I want to have a clearance to areas free of mask of 0.1 millimeter. And if I then go to verify, I will see a lot of errors here. and here, and we have the possibility still to move a word or manually scale a word, but I would like to scale all of the text in one go to 0.9. So if I go to scale all words, we see that directly the errors are removed. Here is still some errors left over, and if I now go to the automatic repair of the frames, I normally should have no error left, and of course the text is moved, we see it into the frame. This frame is moved to the inside and I'm finished with this layer. So very fast and easy. We will leave the YELO suite now and have a look at the secure edge compensation. Very often we were asked from our customers to find a way to reduce the file size after secure edge compensation. We invented two ways to do that. One, boost the speed of file handling with a new option to reduce object count for clearance draws by replacing chains of draws. Setting the UcamDB key clearance manager.smoothen to 1 will replace chains of draws to single draws or arcs wherever possible. The second one, a new finalize option and a checkbox auto finalize have been added to the Secure Edge GUI to prevent negative objects. Finalize to run Netlist and expand through objects on active layers manually, or checked auto finalize will run automatically at the end of apply to eliminate the negative clearance draws. So in the first part we still have the negative objects. In the second part we will not have them. Let's have a look at that. In the Secure Edge GUI you now see a finalize button. This is to manually eliminate every negative object by expanding through objects. The auto finalize toggled on will directly run after the apply and therefore eliminating the negative objects. If you would like to try the key, please go to UcamDB. Add in a new key for clearance manager.smoothen and set it to 1, and then it will go and clean up the used data, so every negative part of it will be optimized. I let that run in the background so we can have a look at it later. For now I will show you the difference in the keys. I created them before. So the original layer is 19 kilobyte with the key of 0. So the way we had before, it is 829 kilobyte. With the key set to 1, we reduce that again to 168. And the autofin, so the auto finalize, is reducing the data to 171. This is based in more objects used for the contours. So which way you prefer, it's up to you. Let's have a look at the job we let run in the background with the new key set to 1. If I go to selecting all reverse data, I have 962 objects. If I let it run again, but with the key set to 0, we want to delete it first, yes. We will see 8,475 negative objects. So I think the reduction is enormous. The next highlight on our list is bringing us back to our YELO suite. The YELO Mask Adjuster is a beta version, and the trial is extended to this release as there was great feedback in the initial trial period. An option to remove existing wire mask openings was added. The clearance and overhang to outline was implemented. We expanded the functionality to adjust wire openings to the middle of the annular ring between a hole and the copper pad. And the handling of cutouts and inner route was implemented. Rings for non-plated slots were added too. Let's have a look at the data. So let's start with the wire pads. As you can see in here, we have a lot of wires, but they are covered in mask. If I now want to show the new option with the middle between the hole and the copper pad, and I let it run, there you can see the mask opening in magenta is in the middle between the hole and the copper pad. I will use the newly created wire openings to show the remove existing wire mask openings. This will remove already existing wire mask openings or the ones we have placed there. Directly see them gone again. The next topic we implemented is the outline handling. This is not only the outline handling for the PCB outline, it is for cutouts too. If I show you the image outline we have here, you see a small cutout in here. And if I run this option, I activate the layers I want to have and let it run through. Now directly we can see there is a line now around the PCB and we have a new opening over the cutout. I make it a little bit more visible. Here you can see that the mask opening is 0.3 millimeters bigger than the cutout, and on the outside of the PCBs you see that we have a new line in there which is double the size of the edge clearance, so 0.6 millimeters, where 0.3 millimeters going to the inside and 0.3 millimeters going to the outside. In case a copper is too near the outline, it will be handled like this. So I show you the copper in blue in this case. You see that the solder mask opening will respect the 50 micron overhang, so no copper will be exposed. The next development we have in Mask Adjuster is the handling of non-plated objects. So that could be a non-plated hole or a non-plated slot. Both will be handled the same way. Let me show it in this job. If we now have a look at our non-plated elements, you see the green is the hole, the yellow is the solder mask opening, and you see the mask opening is smaller in this case. In that case, the mask is bigger, but maybe not to the same size. This one is exactly the same size for mask opening and hole. And in this case, there is a mask opening missing. So if we go to our functionality and let it run, we see directly that the one where it was smaller is now nicely opened, 100 micron around. The one where it was opened, it is 100 around exactly. The one where it was the same size is now respecting the set value, and we added in a mask opening for the one where it was missing. The next item on our highlight list is interesting for all our Ledia customers who are sending the data directly from UcamX to Ledia. With the new hot folder solution, you will be able to send data to expose on the Ledia machine without taking care of the CU9000 software version. UcamX is completely independent of CU9000. It is not sending data directly to the Ledia RIP, but is always sending data to CU9000 by a hot folder. Of course, I don't have a Ledia in my basement, so I will try to simulate something so it will show what and how it works. This is a fairly standard job. I activate my subjobs and the layers I want to output. I use my output in there like you do it now too. I have some of my settings in here. And if I go to output, it will not go directly to the Ledia, but we have a hot folder. And if I go there, we directly see the file from my job, Ledia demo, is in here. And if I open that, we can see the DPF data and we see the XML file. The XML file contains all the information needed on the Ledia to have the right scaling and the board size and so on. So all information in an XML. What is happening on the other side now? So I will simulate that, and I started a CU9000 and the hot folder solution. So this is starting to work directly on my job. It is loading the data and we have the countdown here. And we see the data. Both layers are visible. We are generating the output of the Ledia demo job. After it is finished, I don't see the entry in the hot folder anymore. This is empty now. And if I go to the processed area, I see it directly in here, Ledia demo, with the date code from now. If I have a look at the SLI queue, I can see the job is processed and have it in here. I hope this was giving you an idea how the hot folder solution is working. Now up to the next topic. The optimization of our ODB++ output. The ODB++ output takes into account the scale factor allocated to a block aperture definition, which was previously ignored. I have an empty job, and to explain what this is about, I will load two layers. And if I have a closer look at them, I have one with a scaled block. So if I go there and query my standard blocks, I see there is a scaling in there of 0.5. If I don't have that, the job is looking like that. So the job is double the size as it should be. In older versions, the ODB output was ignoring the scale factor. So if I import my ODBs, I'm now going for the old one. We directly can see this is not the image we want to have. Our new release solved that and is respecting the scale factor. And if I now read in the output, I can directly see that it is looking as it should. Now we are at the end of the detailed demo. These are only highlights of our new 2021.04 release. A list of fixed issues can be found on our homepage on ucamco.com. The installer can be downloaded from the UCAM FTP download server. We recommend to use an FTP client. We recommend to install this update at your earliest convenience. For any further questions, please contact our local business partner or the UcamCo help desk. For all of you who are interested in a short overview over the past releases we served our customer base with, please have a look at this table. I would like to thank you very much for your attention now. For more information, please do not hesitate to contact us. Thank you and goodbye.